Hi, this is RC Jim, and I've got another unboxing video for you. And what is it going to be? Well, a little while ago, I did a unboxing video on that little jet up there, the F-16. And we got a bunch of other planes around. Is it going to be this little toy car? No. How about a couple of vintage cameras? No. Oh, what's this? Great big box. Well, it says that it's a 90mm FA-18C Hornet. Whoa! Well, there's a story behind this. My son, who is a pilot and flies for the airlines, he was visiting recently, and we went flying, and we flew that little F-16 over there, and I had a good time with it. Yeah, it was good. It was cool. Now let's get, yeah, there it is over there. Don't know where I am, but okay, we flew the little F-16 over there, and I had a lot of fun with it. And my son said, "Well, Dad, you know, that's pretty good, but you really need to get a bigger one." And I said, "Well, yeah, that sounds great, but I can't afford a bigger one. You know, I'm not like the big YouTube channel guys that get given planes to try out and stuff. I got to buy mine." So anyway, he said, "Well, I'll buy one." And so I figured, well, he's going to buy one, and then when I go and visit him, I'll be able to fly it. And this is what's happened. Okay, we just took delivery of this today. So we get to do an unboxing video, courtesy of my son. Thank you, Steve. Appreciate that. And we will see what's inside the box. Well, this is built like Christmas. I guess a Feast of Purim is going on over in Israel at the moment. But I'm not Jewish, so I don't think anybody would be sending me a present for that. A little bit of a rip down here, but I'm guessing that they have plenty of good packaging in here. Freewing delivery. Okay, early model FA-18 Hornet, 30-day warranty, Motion RC, okay, Motion RC, so they are related to this Freewing outfit. Okay, we've got some decals here, so it's showing the Blue Angels livery. And back in Michigan, where I grew up, around the 4th, well, on the 4th of July every year, I think, they have a flying display of the Blue Angels. And I've seen those guys flying this plane in that place. So, stickers to stick on, it looks like. I've got hats. One signed by a member of the Thunderbirds aerobatic team, and one by the Australian Roulettes aerobatic team. Okay, looks like a nice solid set of wing. Feels like it's a decent set of foam. We've got some bits and pieces here. Yeah, lots of little detailed bits that will go on someplace. We've got instructions. Oh, yeah. Sounds like it's got retracts. Okay. Multi-function control box. Freewing multifunction control box enables pilots to efficiently organize all the control wiring inside the aircraft within a single centralized location. Control surfaces, wing connections, landing gear, sequenced landing gear doors, and even sequenced LED lights are all consolidated within the MCB. The MCB is suitable for use in foam or balsa aircraft with servos rated at 6 volts or less. Okay, can accept 12 wired outputs and has 6 input channels. Okay, they've got a plug and play, an ARF, and the airframe only. So the airframe only, no electronic equipment. ARF Plus has got servos installed, and plug and play pre-installed all electronic parts. I think this one is the ARF. I think ARF Plus version, yep. Okay, so we're going to have the servos all installed. So we've got another wing. Got the tail surfaces. Let's go ahead and put this back in here. Out of the way. There's our fuselage. Okay, got the vertical fin. Oh, 2 vertical fins, that's right. Bit of redundancy there in case somebody shoots at us. Got the nose. That's magnetically attached, I believe. They even give you some glue. Wing spar. Oh, these would be the bits on the outside of the wings. And we've got the pilot. Oh, looks very good. Got lights. This is one significant airplane. Okay, so that's going to be where a ducted fan goes. I'm assuming it's not included in the plug and play one, or ARF one, sorry. So it looks like really quality stuff in terms of the control surfaces. And little ball joints. Servo horns cut off from what they originally would have been. Attaching points for the wings that bolt on. Got retracts. That's pretty fabulous. Even a nose wheel that retracts. Okay, and back here is going to be our ducted fan. Now let's get a screwdriver and have a look. Gonna have to figure out how to put this in the hanger or on a hanger. Looks like we got a tail hook for carrier landings. Okay. Oh, we do have a ducted fan. Okay, so it's got the 90mm ducted fan. Oh, that is impressive. So one ducted fan, blowing air out of the two nozzles. That is excellent. Very impressed. Especially given I thought I was going to have to buy one. So this is really good for a ARF in that they often will make you buy the motor along with the servos and stuff. And this one comes with the servos and with the motor. And I think with the electronics control box. Okay, so now that we've had a look, why don't we look at the instructions? Never hurts. 12 blade 90mm ducted fan. Okay, install the main wing. I've decided to use these old cushions that I've got here to be something to set that on. I think that's going to be better than my stand that's really designed for more roundy sort of airplanes. So this is looking pretty good here like this. And the first thing that we need to do is to attach the wings. And so we need the spar. It's nicely in the tube, no problem there. Those are going to be for the ends of the wings. Okay, start out with a far one. It'll be this one. They're upside down. Everything is nicely enclosed in plastic. Okay. Okay, shows a connection for the radio. Okay. Get these guys to get out. Okay, that's that one. And this is this one. Okay. Okay, and it looks like there's only one way it can go. Okay, so you got the little tabs on the bottom, and little slots that the tabs go into. With these things, you want to make sure that you get them plugged in all of the way. And that's not going in real easy. There it goes. Okay. You definitely have a very solid click when it finally goes in there. And that's what we like, is solid clicks. Okay, and now we're going to feed the cable back in so it doesn't get pinched as the wing goes on there. Okay, just coaxing it in, and that looks good. Okay, we've got slots where the bolts go in and the wing, which allows to make sure it's in all of the way. So we're going to need some carbon, or not carbon, we need some screws. Use the screws. We have screws along with the glue. So you find the screws where you see the tube of glue. Okay. And I've got a variety of things in here. Got the part list there. As usual, this type of thing, I like to have a container that I can put things into. Don't want to lose anything. Okay, so the screws we want, 3x6mm. That looks like a 3x6mm. There's 4 of these. Okay. screws. So I've got them in most of the way. I'm just going to push to make sure the wing is in all the way. I'll start out with the front one, and then I can push back on the wing a little bit and get the second one in. Okay. Okay, so those are nice and snug. So we've got a cable attached, we've got the wing in there, the carbon tube is in place, and we've put 2 bolts in, referred to as screws. So next wing. Okay. That's this wing. So there you can see the connector and the cable, which has got the 2 bumps on the bottom. I put the 2 bumps in the 2 slots. And it goes nice click to get in place. Push our cable in. It would have been easier had I not pulled it out all the way, huh? The other one was a lot easier. This one seems to be snagged on something. Okay, I'm just going to see if I can get at it from the front. Okay, yeah. Okay, inside here, these 2 cables are coming through. And I should be able to pull on it to help it thread in there. Okay, I think it's this one. Oh, there we go. Okay, so what's happened here is having a hard time pushing it in there. Let's just get the camera over here. Okay, we're trying to get this cable pushed in there. You can see that on the controller thing here, we've got the 2 cables coming in. And what I've done is I pulled that back out to where there was nothing where it was tangled up or anything. And that allows me to then pull on it. And as I pull on it here, that's going to allow it to feed in, so it's not all jammed up. So I recommend that you get the cables put in with a plain right side up. You use a little bit of a tug on these to get them through. Don't pull on them too hard because you don't want to damage anything. But then after you get the wing on, then flip it back over and do the bolts. Okay, so I got the cable there. And just a tiny bit of little coaxing. Get those things lined up, and that goes together sweetly. Now I can take it and flip the whole thing over. You could probably run those cables for both wings, and then after you've got them both on, then put in the screws. Having some magnetism in the screwdriver is handy. That's not anything I did on purpose, but just over time working with it around motors and things, it's just developed magnetism in it. And it's very handy for holding onto the screws. You actually want them snug enough to where they're not going to come out, but don't go reefing on them to where you're going to strip something out. Okay, so we've got the screws in place. Now the horizontal stabilizer. And looks like we got 2 parts for that. Okay. Okay, so the whole thing goes. That's why we got these things the way they are. Okay, so we got ailerons, we got flaps, and I don't know if this is going to be an elevon. And this is going to take what? See, 3x8s. 3x8s. Okay, yeah, I see some 3x8s in there. Yeah, and these have got a tapered head on it, whereas these ones had a flat surface to pull down on. One goes there. Get the first one in very, very loosely to make sure that the other one is going to fit, but everything seems to be really good tolerances here. Okay, so that's our horizontal stabilizer, elevator, whatever they call those things. Okay, use glue to attach the plastic cover in the indicated position. So there's a cover that goes over here, but we need push rods on there before we can put the cover on. Okay, so it doesn't actually say to attach the push rod, but it's pretty obvious that it needs to. Well, we need to put the push rods on there. And I think I'm going to leave these covers off until I'm happy with all of the control deflections and everything. But just noticing in the instructions, they show elevator with a control horn on the control surface, and this is, well, I guess that is a control horn with the ball on the outside thing. And yeah, they're showing use the outside one, and they're saying use the second one out for the servo. And you can see this has been trimmed off, and so the outside one is going to be the second one. So I'm going to go from the outside one onto that. I generally, with these things, like to have them to where if everything fell off and it's right side up, it stays in place. Not that practically it really would, but you know, kind of just the general sort of thing. And we will get that stuck in the hole. We can find the hole. Looks like it right there. Something to push on it. Okay, and then we've got this little guy that goes onto the top of it there, and then it swings around to clip onto the shaft there. Okay, and then with this in the middle, which it appears to be, and this someplace in the middle, we want to adjust this to get it the right length. Be nice if we had a reference to go by. Okay, we do have a bit of a panel line here. Okay, so I think I'm going to aim for that panel line. And I'm just sort of pushing it onto the ball. Yeah, that's right on the panel line. Okay, so you just push it to get that ball clipped in there. So that one looked good, and we'll do the same on the other side. Well, we got the other servo hooked up for the horizontal stabilizer, stabilator, whatever it might be. Now we're going to do the fins, vertical fins, and we got two of these. And I imagine the servo connection is going to be on the inside. And it looks that way. And that's got to get connected onto something. Yeah, it's in there. My favorite grabbing tool is the forceps. I'll grab it lightly. And yeah, I assume that's it. Okay, pull the rotoservo cable along the slot in the battery compartment and install the vertical tail along the slot in the battery compartment. Here we go. There we go. Okay, disguise. It was the clip was just sitting right in there. And it's got a little bit of a knot in it, so I get that out. We clip that on. Okay, we got the brown on the top, so this goes in that away. Okay, push it into where the clips clip down on the sides. Verify that, you know, it's got color up here from something else, but looking farther back on the cable, you can see brown is on the top, brown is on the top, so those match up. And this we can then push back in there. We wanted to. Okay. And I'm looking for the cable inside here to see if I can see what's moving. Yeah, I can see it. And I'd like to pull on that one cable. Yeah, that's it. So I was looking for the cable when I pulled this, which cable it was. And that's back in there a good ways. And I get a hold of it with my forceps. Just gently, because you don't want to damage it. Okay, now I got my finger on it. Okay. I don't know if I want to actually pull it all the way in there. I'd like to have access to it. I don't know how much clearance we have here for this. Yeah, maybe I do need to pull it all the way in there. Okay, so we got it mostly pulled in there, and we got just enough out to allow this to get down. That looks good. Okay, and the screws for that. Pull the row cervical, 6 pieces screws to fix a vertical pin. Okay, FA 3x10. Okay, there's 6 of those and 8 of these, and it says 6 pieces. They're both very similar in length. This has got a square head on it. Also very, very similar in size, but I think the 6 pieces is the clue there. Okay, I'm not sure what the 8 screws are for, but clearly we got 1, 2, 3 on each side, total of 6. That's total of 6. This is total of 8. So that's for something else. Okay, so we got 1, 2, 3 on each side, and so it's these ones with the what do you call that kind of head? The one that has an angle on it. Is the one that you got 6 screws. And so we screw that down in place. Wait for it to snug up. Get the next one. And the next one. Okay, now that we know what to do, we get the other side. This time I'm not going to go pulling it all the way out. I'll leave it in there as far as I can. Isn't it good to be able to see me do these things so that you can do it right the first time? Avoid some of the hassles. I see I do have a bit of an issue here. The hinges have come loose on this. Looks like that's a spring. There's a hinge there and this hinge here. So it just needs to get coaxed down into position, hopefully without breaking it and without causing too much damage. Okay, so that's in place. Okay, so that's good. When we get the electrics going, we will check on all of those things. So, what's next? Got a few little airfoil bits to go on. Again, I'm waiting on putting the covers on the back till after we get the radio going, and I can confirm that everything is fine as far as how the linkages are set up and all of that. But we got some other little bits and pieces here to go on. So we'll see what the instructions say about those. Okay, looks like we got a couple of things here. Yeah, so this bit here is showing underneath here, this area here. So we got two pitot tubes and a it says antenna of nose cone. I don't know if that's an antenna or just simply an airfoil. They obviously put on a variety of different airfoils to get the characteristics, flight characteristics that they want for the plane. Doing all their wind tunnel tests and stuff. Okay, so that might be that guy. Don't want to do a belly landing with this thing. Okay, that has a slot where it can go in however deep you want it. Okay, and then on the sides there's some pitot tubes. There's one, there's two, and I would think they go, oh, again they can, it's a sloppy fit. Well, with the glue they're providing a little nozzle that can go on the end of it. So use the cap to open her up. Put her little nozzle on the end. We assume that whatever glue they gave us is appropriate for the purpose. For this one I'm going to use the glue in the actual opening that the thing is going into. That appears to be plugged off. So we either poke a hole in it. Okay. I think it's pretty symmetrical. Okay. Okay. That guy go in there. Okay, that's those. We'll have some things on the other side. Make sure we don't have any glue on our fingers. Make sure we've got any things that might have got glue put on them away. And now we'll get her turned around. Okay, we've got our nose clipped on. That just pushed on, has a magnet that holds it in place. That will be where these guys go. Okay. Okay. Those guys, one on each side, so I can get my glue back out again. Okay, we're looking for these. We're looking for where these guys go. Well, she's quite an aircraft, isn't she? Well, I'm getting ready to set up the radio, but I want to be able to have stands that allow the tracks to go up and down, and also to turn it upside down while I'm working on it when I get the elevators equal. Anyway, I got thinking about it, and the packaging that it came with has got the shapes. You know, we got these little airfoils sticking up and, you know, various things. But I'm thinking I can have a piece of foam that fits in here and a piece that's there, and have that set on something to hold it when it's upside down. In a similar way, with a part of the packaging that was on the bottom of it, I'll have a segment where the landing gear aren't sitting, and prop it up that way, because this thing just does not fit on my standard stand that I've got for my other aircraft. So anyway, we'll roll with the punches and see what we can do. Well, for this first segment, what I've done is I've decided that I want to start at the maximum width of the fuselage and come back about that far. I've added a little bit extra, figuring that I can end up trimming something off. And I may have to cut some holes for some fins. We've got some indentations in there. But basically I've just used a square to mark it off all around. My saw will cut part way through that, and then I'll flip it over and cut the rest of the way. So we'll get that for the first piece. This is a segment we've cut out, and I've put it onto the plane, and I just have a tiny indentation from the smaller fin on top that goes there. I'm just going to, that wouldn't cause any harm, but I'm still going to cut it out to relieve that little spot there. Everything else seems to fit fine, and so now we'll work on a secondary piece. Okay guys, here's another place where you can learn from my foibles. Okay, I was planning on cutting this out like this, because we got the fins, vertical fins that are coming up here and here, so I want to dodge those. I want to support the tail end of the fuselage, because, you know, the other bit that we've got is forward of the center of gravity. This will be behind the center of gravity. But all it's going to do is, you know, I might end up having to take off more than that. But I got thinking that I should have just left this together and then just cut out a relief for the fins in there. Why didn't I do that? So anyway, I'm going to stick that back together with some tape just to see if it works. Cut out the bit here for the fins. Cut this out to clear the tail. One thing I might mention, you can cut this with just about anything. I use my radial arm saw for most of it. But you can just use an ordinary saw and cut this stuff. And, you know, this is not going to be what's on display. It's just to work on the thing. So you might think about that as to what you can do for your own purposes. And you might have a stand that works perfectly well. But I just thought I'd try this to see if I can have some decent sort of working way to work on the plane without so much hanger rash. Well, for the moment, we're going to pretend that I didn't cut this in half. Okay, so there we got a segment to support the fuselage. We got relief in there for the two fins. I've got a piece of board here that is going to support that, and a stand that's going to get it up off the ground. Tail is going to be out this way so that we can be looking at that. And the center of gravity ought to be someplace in here, so it ought to balance. So let's see if I'm right. One disadvantage to cutting styrofoam is you get little bits of stuff all over the place. Okay, so it should go in there someplace. Hard to tell if we're in the right place or not. There we go. Okay, just noticing that the fin up here has got a relief for it, and the fin over there has got a hole for it. So no problem with the fins, and now we got a nice stable working platform for when the thing is upside down. One of the things that we'll be doing here is that I see I've got these elevators slightly kinked, and given that they're only going to be using either a Y harness or the equivalent with their control thing, we certainly need to have those things straight. But I want to make sure that the servos are in the neutral position, which they probably are. Well, that one isn't. I might have them closer than what I thought. But anyway, we'll get that in the neutral position and make sure that we've got those things dead straight. And this allows us to do work on the bottom, and we've got clearance off the ground. So for here in the workshop, that may not be a solution for the field, but here in the workshop, that's a great solution, a nice steady platform to work on. So now I want to have a support from the other side, so I can have it right side up working on the radio and cycle the retracts. So we need to support it from back here and up there in this area. This is where the air intakes come up to, so I'm going to use that as a datum to measure back from to work out what I want. And with this one, I guess I could cut a hole for the retracts there. The center of gravity is going to be anywhere. Without the battery, the center of gravity is back here. With the battery, the center of gravity is up there. So I need to be able to support it in that whole range of where it might be. And also you want it steady. We got to clear the tail fin. Well, here we are, and it's looking good. One interesting thing with this bit of MDF or whatever it is that I've got under there and these plastic trays, allows me to move this thing around if I want to see it from different angles. And as far as this bit for the holding it right side up, that fits very nicely in there. So I've cut it to clear the wings here. On this one side, I've had to cut it to clear the servo arm and control rod. I've got clearance in here for the landing gear. I've cut this on an angle, as the landing gear are going to come out at an angle, but I don't think it's actually needed. It could have been straight. I've got support fore and after center of gravity. Center of gravity can be anywhere from here to there. So that should balance okay. And we've got clearance above here because of the things I've got it set on. I can get at my linkages here to adjust them when it's this way, or I can work on the landing gear. Now if I'm working on the landing gear, I'm going to have blocks of wood here and here so that there's room for the landing gear to come down. I can't have this set on that MDF. If I'm just working on other things, the MDF is fine, but landing gear, we'll have a couple of 4x2s that we put in here. And we'll have the nose gear coming down from up here and the main gear coming down from there. So, all looking good. Now that we've got our work stand, we can start thinking about the radio gear and what we need to do. It talked about a servo for the nose wheel. It's already got a variety of things in there. I guess we'll hook up the battery and then we'll see what we got. I'm guessing that's all in place. Of course, we'll have to hook up our receiver and plug in the channels. They're all nicely labeled as to what goes, and they've got, there's supposed to be 6, looks like 7. What do we got? reverse brake. Huh. Okay. So if you have a reverse on your yeah, just to throw it in reverse, you could throw it in reverse. Not sure how much that's going to do. You never know. So you got throttle, landing gear, elevator, aileron, flaps, and rudder. Okay, so we won't be using the reverse brake, but I'll get the other 6 hooked up. Now, before we bind our receiver, and I'm using a Spectrum AR620, but before we do that, we want to make sure we've got the channels right. So if you go into your system setup and channel assign, then that shows you what the various channels are. So we've got throttle, aileron, elevator should be next. Where's elevator? Tag must be on the bottom. Yeah, there's a tag down there. Get the tag up on the top so we can verify everything. Okay. That is on that one. Okay. Throttle, aileron, elevator, rudder, landing gear, flaps. Okay. We do have the potential to put a reverse switch on there, but I'm not going to be using that. Okay, so we got that there. We've got ourselves up on these stands here, big chunks of wood, so that if the wheels, the landing gear come down, they've got the freedom to do that. Also, it's reasonably secure so that as I'm holding on this, when I bind it, nothing's going to go anywhere. So binding it is the next thing we want to do. Of course, I might mention with the aircraft type, with this type of setup, because it's got the little distribution box in there that's sending the signals everywhere, it's just got a single aileron lead. So you act as if there's only one servo on the aileron, and same thing with the flaps. There's only one lead for the flap, so even though there's servos on both of them, it acts as if it's one. So one aileron, one flap, normal tail. And again, even though we got 2 rudders on there, this thing is working it all out and connecting everything. So that's how you set that one up. So we get it down here to bind. And I might mention, as we look at the batteries, my son gave me this 6,000 milliamp hour 6S battery. And they specify from 4,500 to 5,500. So this is a smidgen bigger. I already had this 4S 4,000 milliamp hour battery, which is a smidgen smaller than planned. What I'm planning on doing to start out with, if I can get it balanced with this one, this is one I'm going to use because it's a lot lighter and it should just make the plane easier to handle and fly. This thing will do 100 miles an hour, so easy I think is going to be good. Okay, so for right now we're just going to set her in here, and we got the power. Oh, got the wrong connector, so I'm going to have to put an adapter on that. So, well, this one's got the right connector on it. We'll use a heavy-duty job for getting started, and then we will debate about whether to use the lighter one later on. Okay, so we got that in there and nothing has fallen over. Okay, get the receiver out where you can press the button. The transmitter shouldn't be right next to the thing when you bind it. So I'm going to have it here behind me. And once I get that going, I'll have a hand here and I'll hit bind on the transmitter. Get it all set to go. Okay, so that's all set to go. So I've got my arm on the plane to secure things. And it looks good. I'm going to go through any startup procedure. Okay, now we'll push in the bind button and bind on the transmitter. Okay. Okay, so the bind is complete. And we got elevator going the wrong way, and that's with the flaps. I guess that hasn't been set up. Rudders go the right way. We'll not try the throttle just yet. Okay, so she's all bound. Got some nice bright lights that go on there. And so I got to sort out the flaps, and got to reverse the elevator, and we've got to set up the kill switch. Okay, now the next thing I want to do is to have a look at the tail, and what I'm going to do is sight down these tail surfaces to make sure they're both even. Yeah, the right one might need to come up a bit. So this is where it's good to have not glued on the thing. Okay, I want to go up maybe a half turn. So we unclip it. Get it out of the thing, and we want it to go up a half turn, so that's out. Yep, that looks mighty good. Put the clip back on. Very good. That rudder, pretty good. Very good. I don't know, this rudder is just a teensy tiny bit to the left. But I think any sort of change I make on that is going to throw it way off, and it's mighty close. Interesting how things can be different that way. Okay. So we're happy with that. Ailerons are going the right way. Flaps are working. Okay, so from this standpoint, I think you can see that we've got our elevator nice and straight. Goes up and goes down, and gives us an awful lot of movement. This thing is going to be quite agile. Right aileron, left aileron, right rudder, left rudder, and of course we got throttle, which I won't mess around with right now. Flaps. Got 2 steps of flaps. Looks like it'd go farther if I wanted to, but for now we will stick with something like that. Well, I've just adjusted this aileron over here to get it even. Of course I've got these flaps to where I think they're pretty equal. Yeah, they look very equal. So it's lined up here, but I've also sighted in from behind to have a look to try and make sure it's right in the middle. Of course, with trim adjustments, we can make those minor adjustments, but it was pretty well off when it first started. For these covers on the back, we just tack them into place. Interestingly enough, there was actually 3 spots on here where I've just peeled off the glue off of there. Where they've been tacked on before onto something, and I don't actually see any indication of it being on this plane, but it's possible. And I'm not sure if this is the kind of glue that peels right off or not, but we will give it a try. So I'm going to just put a bit of a dab in each corner, more or less. Okay. And we'll be careful not to get it on the rest of the plane. Now, as far as weight and balance is concerned, in the book they say 88 millimeters back from the leading edge. It's about 90 back to the edge of this plastic bit where the wing attaches on. And that's the same on the bottom. That's something that you can feel. Another video that I've watched, they talk about how hard it is to fly this plane. And they reckon a tiny bit behind where it was recommended is appropriate. So I think we'll shoot for that line at the back there. So I'm starting with my 4,000 milliamp hour battery. I've got it about a finger width behind the foam at the front of that compartment. And that balances pretty well. So I get my fingers underneath here, get it on that line at the edge of that plastic, and that's balancing pretty well. Tiny bit, fingers depending on which way it's sitting, but yeah, that's mighty close to it right there. So certainly that'll be flyable, and we'll try it out with that. And trying it out with a smaller battery, we'll start out with very short flights, and we'll see how the battery goes. Also, here in a bit, we'll do a test of the thrust and the amps to see how much power it's drawing. I always like to know that ahead of time. And then we'll be ready to... I've got the Expos set, but we're going to... They recommend having lots of control throw, because when the plane is going slow, it needs a lot of control input. The guys in this other video that I watched, they actually bypass the central control unit and run these elevators on separate channels and mix them with the elevator. And they have apparently the real plane does this. They have the rudders both go in, which helps pull it back. When you're taking off, when you put on the flaps, it pulls those in a little bit with mixing, and helps to pivot it taking off. But that's not part of the model as it's delivered, and as it's delivered, it's got this control unit. So we're going to try and do it as it's delivered. And later on, if we want to try and get fancy with some of the mixing and things like that, we can give that a try. But right now, we want to let you know what's going to happen if you use it the way it's designed to be used. And given that the other guys were having heaps of problems in terms of control and controlling the flight, who knows, maybe the way they set up the controls, where they've gone away from the manufacturer's setup, that might be part of it. But we don't know until we try. Well, we're getting ready to do our thrust and amperage tests, but while I've still got it upside down, I thought I'd have a look at some of the gear in here. Of course, you got the nice landing light. It's mechanical flap doors, so you don't have to worry about any sequencing or anything like that. The gear just comes down and hits on that. It's a nice action on the suspension of the front wheel. It's sort of a trailing. It allows it to go back a bit, which is very important if you land on the grass or something. It needs to have that back movement. Same thing with the main gear. They are rather snug, and they got the right movement. It's just a little bit binding in there, so I'm going to put some lubricant in there. And it certainly doesn't move much. It needs a lighter spring in there for the weight of the plane, but at least it has the right set of action. So that's good. And again, we've got mechanically operated gear doors, so just simply the gear coming down pushes on the little panel there and shuts the door, so that's all good. Tail hook we got glued down, so we're not doing anything fancy with that. This, I imagine, is for looks. this strut here, just to give it a bit of scale appearance. Yeah, this plastic thing just follows along in a track as if it could do something, but it's actually being operated by this retract servo in here. So all in all, you know, pretty happy with the build. Big question will be the flying. They give you these stickers along with a thing to show you where they're supposed to go. But I tell you, trying to get these things off, I have done everything I could possibly do to try and, you know, get these things to peel off of there. And I just can't get them to get off in one piece or in a way that they can get stuck back on. You know, it's totally ridiculous. So the stickers are kind of hopeless, and I'm not sure who their translator was, but they didn't even spell their own name right. You know, instead of Freewing, it's Freewinny. They mistook a G for a Y. And when I say Freewinny model, you know, that's a bit crazy. So it'd be nice if these things actually worked. And I have seen them stuck onto other planes, so you'd think that somebody's been able to do it. So if you know the secret, let me know. You can see it's embossed slightly where you're supposed to be able to peel something off, but there sure doesn't seem to be anything on this to peel. You know, it's like they printed it on the wrong paper, you know. Instead of printing it on sticker paper, they just got a glossy, heavy, ordinary paper and printed it on there, and then it's totally not stickers. Okay, we're now all set up for our test of thrust and amps. So we got the plane set up on a bench. Got a safety rail here fixed to where if the thing was to get loose, hopefully it would stay put, at least for long enough to shut it down. Okay, I've quite often I'll use the horizontal stabilizer with a strap on it to hold it, but with a swept back flying rudder thingy, or flying elevator thingy. Didn't figure that would be secure, so I've run the rope around the landing gear and then brought it back over top of this and then hooked it up to our little scale, not just a little luggage scale. I've tied that off on the radial arm saw. I've got the block of wood under there so it doesn't have any weight hanging on it when I zero it out, so that I've definitely got zero. And then when the plane pulls tight, it's lifting up very slightly on it. So I think that'll give us a very accurate reading of the thrust. We've got our watt meter in between the battery and the plane, and just double checking for things that'll blow away. It especially likes to blow away things, so those papers back there, I'll have to get those out of the way, but then we'll be ready to go. Okay, I think we're ready to go. We power on our transmitter. Freewing FA-18, that's the right one. And we get ready to power on the plane. Everything is secure. It's going to clear the, you want to make sure it's not going to push on the safety bar there when it is pulling. Okay. Okay. We zero out and turn on our meter back there. That will remember the setting. Okay. Okay, we made 103 amps, 2385 kilograms. Okay, but that's not as much as what we would like for the model. Okay, we're going to rerun the thrust test. That last one was done with the 4,000 milliamp hour battery, but I'm an XT guy, so most of my connectors are XTs. And of course we got a EC connection in there, and so I I was using the alligator clips to connect up to it, plus we're running through the watt meter. And I'm just wondering, if I connect directly with the EC5s there, my watt meter won't hook up to it because I don't have the adapters for that, but I can test the thrust and see if that improves the thrust at all. It shouldn't be that the battery makes any difference, although this one might be charged up a little bit better. Let's get the meter and check that out. And certainly it delivered the amps with the other battery. So 106 amps. I don't have anything that draws that kind of current. Okay, we're at 98%, 25.09 volts. 25.09, so our other test was done at 24.35 volts, so that 1 volt is going to provide another 1500 RPM, or I'm not sure what the kV rating is, but that little bit extra RPM and correspondingly a little bit extra thrust. So let's see what it does in this situation with this battery. Okay, so everything is safe, throttle down, got the right model. This is all secured. Now we plug her in. Okay. Okay. And we're mainly thinking about the thrust, so I'm going to get back here where I can watch it. Arm the throttle, and off we go. Didn't have the meter turned on. Okay, so the meter's turned on now, and here we go. Yeah. 3065 grams. 3065 grams at 2509. So another 600 grams, 25% increase with only a 4% increase in voltage. So I reckon the extra current that it's able to deliver through that has made that difference. Now, 3 kilograms is going to be up in the range where we need to be, because I think this is around a 3 kilogram model, but that is what we're going to check next. Okay, let's see what we got in terms of weight. Models are interesting to hold on to. I'm going to set it on my toe, with the nose on my toe. Okay, get this up here. Ooh, 3720. That's with a big battery in there. Now we're going to try it with a smaller battery. $34.15. Okay, now what that tells me is that in terms of acceleration off the line, this is not going to do as well as my other planes go. We generally try to have the amount of thrust equal to the weight of the plane. So I'm going to have to make sure and allow plenty of room to take off. In the instructions, I think they say the minimum distance is like 25 meters. But we'll see. I imagine it'll still allow it to go real fast just due to the nature of a ducted fan as compared to a prop. But yeah, we'll see when we get it up in the air. Well, I'm RC Jim, and this unboxing and build of this Freewing FA-18C I trust has been a help to you to get an idea what this plane is all about, what it can do, and what it might be like if it's sitting there in your hangar and flying at your field. Well, be sure to subscribe if you haven't done so already. Keeps all of these things handy, and of course, as soon as we fly it and see what the flight characteristics are like, we'll be reporting back to you concerning that. So you have a great day, and happy flying!